In this series of 3 videos, we're going to be looking at the topic of quadratic inequalities. And so we're going to have 2 examples that have to do with that. And then after we've done that, we're going to go back and revisit a problem that has to do with the discriminant, where we're going to have an equation, and we're supposed to try to figure out the value of r that gives us 2 distinct roots, 1 real repeated root, and no real roots. And it turns out that this is going to involve solving a quadratic inequality. So for example 1, I guess I would challenge you first to maybe turn off the video for just a minute or two and see what you can do with the problem first. So it says solve algebraically and then check with your graphing calculator. So you want to solve this algebraically, this inequality. 2x squared minus 5x minus 3 is greater than or equal to 0. So like I said, take a minute or two just to at least get it started, and then turn the video back on and watch. Okay, so if you are back, I'm assuming that you've given this problem a try, and I just want to make a comment on this about how many students approach this problem. So you can see that we have a quadratic, and so you may have tried to factor it, and I'm not going to go through the whole factoring process, but this will factor as 2x plus 1 times the quantity x minus 3, and if we check it, notice that the firsts give us 2x squared, the outers give us negative 6x, and the inner is positive 1x, so that's the negative 5x, and then the last give us negative 3. So we're fine on the factorization. And then it still says greater than or equal to 0. So I'll tell you an approach that students often take with this problem, and maybe this is the approach that you took also, is that, we're used to this being an equation where it says equals 0. And so we would set this equal to 0 and this equal to 0. So it seems kind of natural to say, all right, since this product is greater than 0, maybe what we can do is say that 2x plus 1 is greater than or equal to 0, and x minus 3 is greater than or equal to 0. Right? And if both of those factors are greater than 0, then certainly when we multiply them together, we're going to get an answer that's greater than 0. So that makes sense. So when you do that, over here you're going to end up with x is greater than or equal to negative 1/2 when you're finished with the calculations there. And here we get x is greater than or equal to 3. So if we think about that these are joined with the word and we think about a number line, we put those two things together. One of them is saying x is greater than or equal to negative 1/2, which would graph like this, greater than or equal to negative 1/2, greater than or equal to, so I put a solid dot on it. And then greater than or equal to 3 looks like this. And then because it says and, that means intersection. So we're looking for where those overlap or where they intersect. Where do we see both red and green? And that's going to be here. So these two combined actually give us that x is greater than or equal to 3. Okay, and if you try a few values that are greater than or equal to 3, like let x equal 3, let x equal 4 or 5, and check them in this inequality, you'll find that that does work. The problem is that we haven't gotten all the answers. So I'm not going to follow this all the way through, but what we also have to consider is, what if both of these are negative? A negative times a negative also gives us a positive. So we have to say, actually, or here, either this happens or 2x plus 1 is less than or equal to 0, and x minus 3 is less than or equal to 0. And the reason it's and is they both have to be negative to multiply to give a positive, and over here because they both had to be positive to multiply and give a positive. So you're going to go through the same steps here, and if you want, you can try it out. What you'll get here is that x is less than or equal to negative 1/2, and so that means that when we put those together, right, it's or, so that means that we have a union, and so this would turn out to be negative infinity to negative 1/2, union 3 to infinity. Okay, so that's a way that you can do it algebraically. You can see it's kind of involved. There are a lot of logical operators that you have to do. So what I want to show you is a way that's a little easier, I think, and it's applicable to a lot of different problems. We don't have to go through all of these logical operators with ands and ors and looking for intersections and unions and so forth like that. So here's the approach that we're going to take. And we're going to do this with what's called a sign chart. So first we're going to look at where they're equal to 0. So where 2x plus 1 times the quantity x minus 3 equals 0. And if we set each of those equal to 0, we can see pretty easily that this is x is negative 1/2 or x is equal to 3. So what we're going to do is, like I said, make a sign chart or a sign number line, I guess. And down here on the bottom, we'll put the x values. So the important x values here are negative 1/2 and 3. And then up here, we're going to put our signs for this expression. So we'll put pluses and minuses and zeros. So we know that when x is negative 1/2, that this turns into 0. Notice if I put negative 1/2 in here, that's a 0. If x is 3, then this is going to turn into 0, so the product will also be 0. Now what I want is for these sections that are here, 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 and here, I would like to know if I pick an x value in each of those sections, is it positive or negative? So what we're going to do is choose some test values. And this technique that you're learning here is applicable to lots of different problems. And then we want to know the sign of 2x plus 1 times x minus 3. We don't care what the actual answer is, we just care about the sign. So I'm going to pick a test value from each section. So down here, I'm going to pick negative 1. In here, I can pick maybe 0. And over here, I'm going to pick 4. So we're just going to test negative 1, 0, and 4. So again, I don't need to work it out completely. I just need to think about the sign. So if I sub negative 1 in here for x, notice we get negative 2 plus 1, which is a negative number. If I sub negative 1 in here, negative 1, that should be minus. Negative 1 minus 3 is also negative, so negative times negative is going to give me a positive. So that means that this section, all of it's going to be positive, right? If one test value in that section gives me positive, then everything's positive. If I sub in 0, this one's a little bit easier. So if I sub in 0, we just get 1, so that's positive. When I sub in 0 here, I get times a negative, so that's going to be negative. 0 is often a very easy test value to choose. So if you have 0 in a particular interval, I would choose it. For 4, when I sub 4 in here, I get a positive. Sub 4 in here, I also get a positive, so that's positive. So remember, we were looking for where is this product right here greater than or equal to 0. Well, we can see it's happening here and here. Now, because it says equal to 0, it means that we're going to be okay to include these endpoints. So if we write it as inequalities, what this is telling us is that x has to be less than or equal to negative 1/2, or it has to be greater than or equal to 3. So that would be one solution. And if you look up here, I wrote it in interval notation, but that agrees with the answer that we got before. Or you can write it in interval notation, negative infinity to negative 1/2 with the closed bracket, because remember that means that one's included, union the interval from 3 to infinity. All right, and again, that's what we got back here when we did that. Now, I said to check it with your graphing calculator. So what you can do is you can let y sub 1 equal your 2x squared minus 5x minus 3, and then graph that. So you can check this on your calculator. When you graph it, you get this. You want to find those x-intercepts, so use 0, the 0 function to find that, so a negative 1/2 and 3. And remember that we're looking for where this is greater than or equal to 0. So where y sub 1 is greater than or equal to 0. So we're talking about the y values, or the function values of this. And we can see all of these points have y values greater than or equal to 0, and so do these. So now when I write the answer, I'm looking at the x values. So the x values for this section start at 3 and just keep going to the right. The x values for this section start at negative 1/2 and keep going to the left. And so now we can see that we're going to end up with, if I write that answer in interval notation, the exact same thing that we got here.